Hello everyone, today I'm going to explain how I added magnets to Super Mario Bros. Wonder for my latest custom level. Just like the Mirage platforms I've talked about previously, this custom mechanic is once again mostly made up of unorthodox uses of the vanilla game's mechanics mixed with some custom visuals. I was first inspired to make a mechanic like this after seeing this section in Get Lucky's mod Oops All Break Time. The puzzle here revolves around flipping the gravity of a spike ball using an on-off block, which is functionally identical to some of the setups in the level I ended up making. In order to explain how this works, we need to have a look at the wonder effect of the level Rolling Ball Hall. This section supposedly revolves around the entire level environment rotating back and forth, causing big spike balls to roll around after the player. However, in reality, this all comes down to some simple tricks. The screen is rotated using a coarse disp angle tag, and only the gravity of the spike balls is rotated using the change world gravity tag. So going back to Get Lucky setup, this works by sending a signal to that same change world gravity tag actor from an on-off block and setting its rotation degree value to 180, causing the spike ball's gravity to be flipped. And this is pretty much how my magnet setups ended up working as well, with one caveat, because my magnets only have a specific area of effect. This is a bit of an issue because the change world gravity tag is universal, meaning it applies its rotated gravity to all spike balls throughout any given area. So the way I worked around this was by detecting each spike ball's presence in a magnet area using an area switch object, and only enabling the change world gravity tag when both the on-off block is enabled and the spike ball is in the right spot at the same time. Although this successfully creates the illusion of the magnets having an area of effect, this still doesn't solve the issue that gravity will always be applied to multiple on-screen spike balls in the same direction, even if only one of them is touching a magnet field. So the solution I came up with for this was to only ever have one spike ball on screen at the same time throughout most of the level. Alright, so that's how the spike ball setups work, but I decided it would be fun if the magnets could interact with multiple mechanics, which is why I also made them move pipes. The core system that allowed me to do this is Super Mario Bros. Wonder's reciprocate tag object. Reciprocating motion is basically a technical way of describing something moving back and forth. So by tying an object like a pipe to a reciprocate tag, it can be moved back and forth whenever a signal is activated. So by hooking this tag up to the same on-off block that controls the spike ball's magnetic movement, and messing with the reciprocate tag's timing and distance values, I managed to create another somewhat convincing rotated gravity effect. Normally, this tag will continue its motion until it reaches its endpoint, even when the signal it has received has been deactivated, which could cause the pipe and spike ball to sort of go out of sync. But this enable toggle always checkbox changes that and allows the pipe to change direction spontaneously, just like the spike ball. Something which I couldn't quite fix as elegantly, however, was the smoothed out motion of the entire thing. If we look at the way the spike ball moves when its gravity is shifted, it starts off slow before gradually speeding up, reaching its highest speed just before it comes to a stop. In comparison, the pipe starts off slow and gradually speeds up, but then also slows down again as it's about to come to a stop. This isn't realistic as far as the motion of something that's being pulled around by a magnet or gravity goes, but sadly I didn't really have any other options. Okay, when I did have other options, this easing type value changes the motion of the reciprocate tag quite drastically, but the problem with the values that do display the right type of ramped up motion is that this then happens in reverse once the signal is deactivated, which is the exact opposite of how it should look. So that's why I settled for the compromise of having the motion of the pipes be eased on both ends. Okay, so this is roughly how far I got with this whole idea in its original incarnation, which was nearly a year ago. I then ran into a problem with the magnet gimmick, which I will go into in a bit, causing me to give up on it for a while as I focused on other level ideas. It wasn't until quite recently, as I played through the Super Mario Galaxy games on Switch 2 with their gravity shifting mechanics, that I was reminded of the existence of my Super Mario Bros. Wonder magnet concept and decided to give it another shot. And since I'd already done the legwork of figuring out most of the functionality of the mechanic last year, it was now time to focus on visuals. Again, I should emphasize that because all the inner workings of the magnet mechanic are handled by the in-game setups we just discussed, the actual magnet objects and beams are purely decorative. Now, magnets can be represented by all sorts of things. I considered generic blocks or a stretchable plate or something else I could easily tile, but I ended up settling on taking inspiration from these ice block generators in the original game. So I edited their texture, removing the Bowser stuff and replacing it with a magnet symbol, and did the same for the normal map and Mix Zero texture. My plan at this point was to duplicate and edit these slimy temple blocks because of their ability to light up with an emission texture when they receive a signal. So I also made red and bluish emission textures for my magnets, which would not only light up the magnet symbol, but also apply a glow to some of the block's edges. But then as I worked on making the actual magnet actor, I realized my mistake, because these temple blocks don't light up when they receive a signal, but only specifically when they are moved on a rail. I wasn't planning on moving my magnets around, so I had to find some other way of enabling and disabling these emission textures to show that the magnet has activated. And annoyingly, I ended up having to settle for a pretty janky and inefficient solution, which was to make 3 separate magnet actors, each with its magnet symbol in a different state, and to spawn and despawn each one over top of the other depending on which symbol I wanted to display. This meant setting up each magnet would require working with several overlapping actors, which was not only annoying to do, but also pretty risky because of the game's level actor limit. I've talked about this extensively in a previous video, but thankfully I didn't end up running into it in the case of this level. The magnet beams ended up working in the same way, with the red and blue types being 2 separate actors that overlap and get spawned and despawned when necessary. The idea of having each magnet's area of effect be represented by color-coded beams like this was inspired by both the aforementioned Super Mario Galaxy games and also Mark Brown's game Mind Over Magnet. I knew I wanted them to be colorful, translucent, and also animated in some way, which was quite a big ask because, as I talked about in my Mirage platform video, customizing Super Mario Bros. Wonder's materials is really tricky and often ends in disaster. So I needed to find an object in the original game that had the sort of look I was going for that I could then modify to suit my needs. Thankfully, I found the perfect object, which is the rainbow that appears in the background of the level Robert Cove. This has a colorful translucent gradient effect, including animated scrolling white sparkles, so yeah, it was just what I needed. I remodeled it into a simple rectangle, gave it a red or blue gradient, changed its texture animation to scroll vertically instead of diagonally, and replaced the sparkles with big arrows and smaller particles. The red beam features plus-shaped particles, and the blue beam instead has minuses, because, you know, magnets and stuff. Also, I used a fun trick to circumvent compression on the images used for the gradients. So, as you probably know, video games, like most software, compress their images to be able to load them more efficiently and save on storage space. This is particularly noticeable in the case of dark gradients like the images that my magnet beams used, meaning I could actually see the compression in-game. So rather than fixing this by making the image higher quality or resolution, I instead downscaled my gradients to 8x8 pixels, which counterintuitively solved the problem. Because, as you once again probably know, most software displays upscaled tiny images as blurry gradients between each pixel, which is a process that happens after compression, meaning it makes for a simplistic but in the end better looking gradient. Anyways, these slim beams aren't the only ones I ended up making for the level, because I also created bigger square versions for the level's wonder effect, where the entire screen is covered in a magnet area. And this wonder effect is actually the thing that I alluded to earlier that I got hung up on when I first came up with this whole mechanic last year. See, I knew from the start that in a level that revolves around moving metallic pipes and spike balls using magnets, I just had to use the metal player transformation. And of course, then the ideal thing would be that the metallic players would somehow get pulled around by the magnets, just like the other metallic mechanics. The problem is that there is no way to affect the player's movement using a tag that changes their gravity or anything like that, so finding a way of representing this idea was really difficult. I messed around with some of the game's wind actors that can push the player around, but the problem with those is that they also affect any other non-metallic object that is affected by gravity. So this conundrum is why I originally gave up on the idea. Now flash forward a year and I came up with yet another compromise that I'm fairly happy with. See, the whole underlying gameplay gimmick of the metal player is that you become extremely heavy. So maybe if we say the magnets pull the player up with the same strong force that gravity pulls them down with, then it would make sense for metal players to become weightless when magnetized. So during the level's wonder effect, I enabled this spacewalk tag, which is used in the original game's cosmic Hoppos wonder effect, whenever the player is supposedly being lifted up by the magnet effect. This compromise didn't have the same gameplay potential as my original hopes for the wonder effect, and I'm still not completely satisfied with it, but it's better than nothing. And yeah, that's pretty much it as far as the big and complicated custom actor stuff in the level goes. Another small thing I did was make a recolored duplicate of the timer block actor, since both of the original game's timer blocks are color-coded to suit their purpose, so I wanted the same to be the case for my magnet one. I also wanted the pipes in the level to look metallic, so I added the silvery castle pipe color to the palette used by underground levels, and for more information on how that process works, I'd recommend checking out this short. Finally, I considered recoloring the spike balls to be silver as well, but realized I couldn't change the color of the particles they spawn when they're destroyed, so that would have looked odd. And that's it. That's every magnet-related actor I made for my latest custom Super Mario Bros. Wonder level. If you have any suggestions for some other janky custom mechanic I might be able to make using the original game's established mechanics, please let me know by leaving a comment. While you're down there, maybe also consider leaving a like or subscribing or whatever. I also have a public Discord server linked in the description, and if you want early access to my videos, maybe consider signing up for a YouTube channel membership. Thank you so much for watching, and bye bye!